So we've looked at when we have a base of e for either our exponential function or our logarithmic function. These are actually the easier ones. The ones that we've done before are the ones with bases of e are easier than if you have a base other than e. So we're going to look at the formulas here for taking derivatives of exponential functions that have a base of something besides e. So it could be 2 to the x, 5 to the x, 7 to the x, anything besides e. So we're going to generalize that by saying a. A can be any number except for e. It could even be e, and I'll actually show you how that works out. But what we're going to do is to take the derivative of a to the x, we're going to take the natural log of our base and multiply it by a to the x. So it's kind of got that same aspect of repeatedness that we had from e to the x. If we imagine this, if we use this formula to take the derivative of e to the x, we would have the ln of e times e to the x, and of course the ln of e is 1, so we'd have 1 times e to the x, which is just e to the x. So this holds true based on what we know about the derivative of e to the x. We could think of it in terms of u also. So if I have a to the u, so a to some power other than just an x. So this could be any function. This could be a trig function or a polynomial function, anything. You're still going to have the same thing. You're going to take the natural log of your base, times it by what you originally had, and then you're going to have to times it by the derivative of the exponent. Okay, so which is basically the chain rule again. Okay. Next, let's look at logarithm derivatives when they have a base other than e. So remember, ln is the log base e, and that's what we've been working with. And the derivative of a natural log of an ln is 1 over whatever you're taking the ln of. But the derivative of log base a of x is 1 over the natural log of a. Okay, so that's kind of a common element in these things. We're always taking the natural log of our base. And then we've kind of got this 1 over x part. Where this comes from is our change of base formula. So remember, if we actually wanted to calculate out log base a of x, we could use the change base formula and take the ln of x and divide it by the ln of a. Well, a is a constant because it's the base of our logarithm. So I could rewrite this as 1 over the ln of a times the ln of x. Since this is a constant, when I go to take the derivative, this just stays like it is. And the derivative of ln of x is 1 over x, which brings me back to 1 over the ln of a times x. Okay, which is what we had up here. And of course, if we have something other than just x in here, we're going to have a u, and we're going to have to chain rule it to get our derivative. The only new integration formula we need is the integral of a to the x, because we already looked at the integral of 1 over something and how that reverts back to the natural log. So if we're taking the integral of a to the x dx, okay, we can kind of reference back, and we're working backwards from here. So if this is the derivative of this, if I integrate both sides, okay, that means I'm going to need, okay, this is going to be my constant term, and this is, the variable term. So in order to offset the fact that I have this here, I'm going to have a 1 over that. I'm going to have the reciprocal. So it's kind of a play on what we do for the power rule. But we're just going to have 1 over the natural log of a times a to the x plus our constant of integration. So let's just look at a couple examples. I'll do 2 derivative examples, and then I'll do an integration example. So, derivative example. I want to take the derivative of this thing. Okay, and I can already see I've got a product here, so I'm going to be doing product rule. So, product rule says take the derivative of the first thing, which is going to be the natural log of 5 times 5 to the negative alpha over 2 times the derivative of my exponent. Okay, the derivative of this. Remember, the negative alpha over 2 could be rewritten, could be rewritten as negative 1/2 alpha, and the derivative of this is just negative 1/2. Okay, this gets timed by the second part of my function, plus the first thing left alone times the derivative of the second thing. So derivative of sine is cosine, times derivative of the inside part, which would just be derivative of 2 alpha, which is just 2. So I'll put that up here, I guess. Oh, not up there, up here. I'll just move it over. Okay, there we go. So times 2 here. Okay, so this is your derivative. This is a constant, of course. Let's see what we could do to simplify this. Or not a whole lot, really. Yeah, I could pull out this term here. So I could factor this out. Yeah, I think that's really about it. So then I'm going to have, negative 1/2 the natural log of 5 times the sine of 2 alpha plus 2 cosine of 2 alpha. Okay, so that's the derivative of that. So just same rules, except now we've just got one other type of derivative that we know how to deal with. So we can still product rule, quotient rule, chain rule, all that stuff. Let's look at one with a logarithm. Okay, so here I've got kind of a bunch of stuff going on here, but the outermost piece is this log base 3, and the derivative of log base 3 is 1 over the ln of a. Okay, so I'm going to have 1 over the ln of 3 times this inside part. Okay, so I've got that. Instead of having a fraction and a fraction here, I want to clear this up right away. So if I rewrite it a little bit, I would have 1 over, since ln of 3 is kind of a number, it's going to be in the numerator. And this just means I'm going to reciprocate this. So really this becomes 2 over let's see, we'll do x squared of x minus 1 ln of 3. Okay, so I get that. So that's just the derivative of this. Now I need to multiply by the derivative of the inside part here. Okay, so you can think of this 2 on the bottom as kind of a 1/2 up here to make it a little easier. So now it's a product rule, not a quotient rule, and I usually prefer product rule to quotient rule, so I'll put this in parentheses. Derivative of the first times the second plus the first left alone times derivative of the second. So I drop the power by 1 times the derivative of the inside part, which should be just 1. So let's simplify this here. So we have 2 over x square root x minus 1 ln of 3 times, I've got square root of x minus 1 over 2 plus half times a half is 4. This comes down to the bottom. And then I've got an x on the top. Let's see what we want to do. I can cancel this 2 out here. As long as I do it from both terms. So this becomes 2. And let's see, if I distribute this in, so I'm going to distribute, so I'm going to have square root of x minus 1 on top, x, square root of x minus 1, ln 3, plus x over 2x. And now square root of x minus 1 times the square root of x minus 1 is just x minus 1. And then I've got the ln of 3. This cancels. So I've got 1 over x ln 3 plus, and cancel this x with this one. So now 1 over 2x minus 2 times ln of 3. We'll just kind of leave it like that. We could get a common denominator here if I, multiply this by x and x, and multiply this by 2x minus 2 and 2x minus 2. I guess that's not too hard to finish off. So 2x minus 2 on the top plus x over my common denominator, 2x minus 2x ln 3, and I can combine these to get 3x. Alright, let's look at an integral. So I'm integrating this thing here. This is multiply, and then I can see here that I've got an exponential function, and so I'm going to want to change that to a u. So I've got 7 to the u, or it looks like a 4, u. My u, of course, is, so actually, let's make it u squared. No, we'll make the whole thing u. So u is 3 minus x squared. So du is going to be 2 times u minus, times 3 minus x, times the derivative of the inside part, which would be negative 1. So du is negative 2, 3 minus x. Okay, so I don't have du, but I do have part of it. All I'm missing is the negative 2. So if I multiply a negative 2 on the inside, I would need a negative 1/2 on the outside. So, whoops. So I've got negative 1/2, 7 to the u, and I now have du. In order to integrate 7 to the u, I get 1 over the ln of 7, okay, times 7 to the u. U, of course, is 3 minus x squared. Okay, so all I did there was use this formula. Took 1 over my base, multiplied by that. Okay, I involved u substitution in there also, so then I just need my constant of integration. Oh, don't forget your negative 1/2 that was up front here, so we'll make this negative and put a 2 there. So we get that, and that's my integral. And then if I needed, if this was a definite integral, so if I had some numbers here, and I wouldn't have the constant, and I would, go through the definite integral process.